Welcome! In this mini lecture, we're going to cover the key ideas of section 1.8. Specifically, we're going to be looking at indexed sets. Just as we were able to take the union, intersection, and product of two sets in the past, we can now do that with multiple sets. So we can, and rather than using A, B, C as our set names, it's often more convenient to use A sub 1, A sub 2, A sub 3, and so on to denote our sets. These are called indexed sets. So, just as before, the union of many sets is the set of all elements that occur in at least one of the sets. And just like before, the intersection of multiple sets is the set of elements that occur in each and every set that's given. Now, we're going to look at a more compact notation. Rather than always writing out A sub 1, A sub 2, and so on, we can use this notation, a big union symbol, with something that indicates the indexing of our sets. So, and the index is frequently the natural numbers, although it could be any set that we could imagine. And so this is saying the same thing as what we saw above. These two things say the same thing. One is just much more compact. And similarly, the intersections are the same thing, but again, more compact notation. Now, one thing that you're going to need to be able to do is type this up in LaTeX. The notation, the command you're going to want for, say, the intersection here is /big cap underscore /alpha /in capital I end squiggle. The underscore tells it to be a subscript and go underneath. And then what goes underneath is the /alpha. That gives you the Greek letter alpha. N is the element symbol, I. Then you can continue on after that with your capital A. Again, use a sub with a /alpha. And just as we have big cap, here we would have /big cup. Just using cup or cap is what we used before with our smaller sets when we were only using 2 or 3 sets. So now let's look at how we actually use these. Let's consider the union over our index set of natural numbers of I plus 1. So, what would this look like in terms of what's on a number line? So, our natural numbers, if you recall, start with 1, 2, 3, 4, 5, and so on. So the first one, the first number in our index set, and then the first number in the natural numbers would be 1. So this would be the set 1. 1 plus 1 is 2. So that's our first interval. Our next interval would be, next natural number is 2, so it would be from 2 to 3, and so on. This would continue forever. So if we think about what does this look like in terms of our number line, it's everything between 1 and 2. That's our first interval. The next interval goes from 2 to 3. Those are included. The next one would go from 3 to 4 and be included. So since we're interested in the union, we want to capture everything that's in one of these sets. So it would include everything between 1 and 2, including 1 and 2. It would include everything between 2 and 3, including 2 and 3. So as we continue on, we see that we will eventually cover the whole number line to the right of 1. So the question becomes, we start at 1, we're going to cover the whole number line out to infinity. Do we include 1? 1 is definitely in that first interval. So we have the set from 1 to infinity, that interval. Now, what if instead of the union we had considered the intersection? So we need it to be, we want all the elements that are in every single set. If we look at the number line above, everything in that first interval from 1 to 2 is not in the next interval from 2 to 3. 2 is included, but once we move on to the next interval beyond that, 3 to 4, nothing from that first interval would be included. So, is there any number that would be in every single set? There is not. So the intersection of those same sets is the empty set. Let's look at another example. Again, for these indexed sets, when we're considering their union and intersection, it is often easier to consider what do they look like when we graph them, when we put them in their appropriate plane. So in this case, we're going to look at the union of the real numbers cross the interval I plus 1 like we had above. So now, in this case, what do our sets look like? So the first element is always any real number, because remember, each element of the set is a pair in x, y. The first coordinate is always a real number, so it could be any x, and then the y, in the first case, when I is 1, it would be from 1 to 2. So it's every ordered pair in this stripe on the number line. If we were then to move to n is 2, that's our next natural number, it would be every real number with a coordinate in the y that's between 2 and 3. So that would be this next stripe between 2 and 3, and that would cover all of those pairs. We could continue in this fashion. The next one would be between 3 and 4. And so we aren't covering the whole xy plane, but we're capturing all the pairs of elements where x is any real number and y is 1 or greater. So one way we could write that would be ordered pairs that are elements of R cross R such that y is greater than or equal to 1. Can you think of another way that we might write this? I've just given you another alternative. So that would certainly work. So looking at one last example, we're going to look at the intersection. Again, our index set is the natural numbers of intervals that span negative n to 1 over n. So, again, if we picture this on the real line, what do these pairs start to look like? So the first interval, if n is 1, would go from negative 1 to 1. The second one would go from negative 2 to 1/2. So 1/2 negative 2. That's what the second interval looks like. And the third interval would be 1/3 to negative 3. So the question is, where do all of these sets overlap? Is there anything that is included in every single one of them? Certainly, it would appear that between negative 1 and 0 will always be included. On the right, the fractions will always be approaching 0. So we know there's always that right parenthesis just a little bit to the right of 0. And on the left, we're always going across that negative 1 and capturing everything between negative 1 and 0. So the question becomes, should there be parentheses or square brackets on either side of those numbers? What do you think? Negative 1 is not included because it's not included in the first interval. It does get captured by every other interval, but it's not in the first one. So that is definitely a parenthesis. 0, on the other hand, is included in every single interval that we are looking at, because there's always a fraction just to the right that has that parenthesis. There's the basics of indexed sets. If you have any questions, make sure to come by my office. Have a great day. Thanks for listening.